Hi there. So today we're going to do the first of a couple of lessons looking at binomial expansion. So we started doing binomial in year 1, and the year 2 binomials just a little more complex. So in a moment I'm going to show you the question that we're going to finish with. So you can look at that, pause the video, and if you reckon you can smash that out the park, do it. Go to the end of the video. If you have done, then great. If not, track back and we'll do a few more examples leading up to it. Right, so here's our target question, if you like. Have a good look at that. Binomial expansion of 1 plus kx to the negative 4, kx being the magnitude of k times x being less than 1, is 1 plus 20x plus ax squared plus blah blah blah. Got to work out what that value is there and find the value of constant a, giving your answer in its simplest form. So if you think that's fine for you, then go for it. You would have to be using this part from your formula booklet, but we're going to start off by having a look at some of the stuff from here. So we're going to start with just finding the binomial expansion of x plus 1, or we always write it as 1 plus x to the power 6. But if you think that we started with quadratics and things with x plus 1 times x plus 2 and things like that, this is 1 plus x, or x plus 1, times by itself 6 times. Now you can do this really quite quickly using Pascal's triangle that you may remember, which has all sorts of interesting applications in maths, or interesting sort of patterns in it, but one of them is the binomial expansion. So if you start with 1 and then below that put 1 and 1, and then these two numbers add to make what's below it. So this just gives us 1 plus 2 makes 3, 2 plus 1 makes 3, and then we've just got the 1 at the edge. Then we've got 1, 4, 6, 4, 1. Keeping on going, 1 plus 4 is 5, 4 and 6 is 10, 6 and 4 is 10, 4 and 1 is 5, and then we've got the 1 on the end. And then going one stage further, 1 and 6, 5 and 10 is 15, 10 and 10 is 20, 10 and 5 is 15, 5 and 1 is 6, and that is 1. Now that's really useful in this case, because it turns out, sorry about the bell there, it turns out that if we were to expand it, and I'm talking about doing 1 plus x squared, doing like that, and then we were to take those and to keep on expanding it all the way, it would come out as 1 plus 6x plus 15x squared plus 20x cubed plus 15x squared plus, whoa, not x squared, x to the power 4 plus 6x to the power 5 plus x to the power 6. And that 1 there is really 1 to the power 6, but that gives you 1 in the end anyway. So you get to the power of 6 of this one and this one on its own at each end, and then the number of the coefficients you can get from Pascal's triangle like that. Now you can use this for anything. You can say, if I wanted to know 1 plus x to the power, oh dear, 1 plus x to the power 4, for example, I would just use this one where you see the 4 coming in there. So you've got your 1 to the power 4 plus 4x plus 6x squared plus 4x cubed plus just the 1x to the power 4. So for your simple binomial expansions, Pascal's triangle hits the whole thing nice and easily. Now that's great, but what if you wanted to do 1 plus x to the power 20 and you wanted to know the coefficient of x to the power 4? So what is a there? Now you could carry on, but it's going to take a long time to draw that out, isn't it? So let's just check with this first of all. When you're on the, well, before going to the calculator, you can also go to your formula booklet and you can find it here. Now the place you're looking for that, r would be 2, because sorry, no, r would be 1 there, because that's that's your x to the power 1s, that's your x squareds, and so on. So let's try that out in the calculator. Yeah, you can, sorry, I'm going all over the place, aren't I? So if you put n as being whatever the number is, that would be 20, and then 1, that would be your x's. For x squared, 20 and 2. And we were wanting 4, weren't we? So to the power 4 would be 20 with a 4 underneath. Now, in order to do that so I can't keep bringing this back here, you could use that formula there to put 20 factorial over 4 factorial times 16 factorial. That would be one way to do it. So let's try that now. So we've got n over r, and we are saying we've got NCR equals n factorial over r factorial, n take r. So using what we're looking for here, that would be 20 to the power 4. So we're saying 20 choose 4. It all comes from probability, this little nugget. So that would give us 20 factorial over 4 factorial times 20 take 4, which we do know is 16. So I could whack that into my calculator and get, and it is a bit of a minefield trying to find your way around here. So looking for the factorial button, we would have to go into probability, which means going option, cross to probability, and then there's your x factorial over 4 factorial 20 take 4 factorial, and that gives me 4,845. Or you could go for it using the calculator. So if I come back to where I am normally, if I go for option again and probability again, you see I've got NCR. So instead, if I put 20 choose 4, I also get 4,840. So that's just going 20C4, and that's plenty of working in terms of that. So that means that in that expansion, that's how many x to the power 4s you get. So it's time to make things a little bit more interesting. We've got two unknowns, x's and y's this time. It won't be a totally symmetrical expansion like we had before, going from 1 back down to 1, because we've got 2y instead of x. When you get, you'll have x to the power 8 at one end, and then you'll have 2 to the power 8, y to the power 8 at the other end, won't you? So you'll get many more y's as a result. So you need to remember that. Have a little, pause the video, have a little go before watching me go through it. Right, so first up, we're just looking for the first 4 terms. So the first term is going to be 1 times x to the power 8. But then we're going to have 8 choose 1, 8 choose 2, 8 choose 3 for the next 3 terms. And 8 choose 1 should give you 8. And does. So we can say that that is going to be 8 times x to the power 7 times 2y. So then we work that out as being 8 times 2 gives us 16 x to the power 7 y. Then on the next one, if we just go 8 choose 2 gives us 28 x to the power 6 times 2y squared. So that's going to give me 28 times 4 x to the 6 y squared. So I'm being extra careful here because it's so easy to make a little mistake on this, but it's so common. That gives me 112 x to the power 6 y squared. On to the next one, you do 8 choose 3, and that should give you 56 times by x to the power 5, and that'll be times by 2y cubed. So that's going to be 56 times 2 cubed is 8 x to the 5 y cubed, and 56 times 8 is 448, so that gives us 448 x to the power 5 y cubed. So then all there is left to do is just to write that out properly. X to the power 4 plus 16 x to the 7 y plus 112 x to the 6 y squared, add the 448 x to the 5 y cubed. Right, and this is our last little year 1 reminder before we look back at that question we had at the beginning. So things start to get a little sneakier. They just want the term in x to the power 5. So that is the one where it's actually the 6th term, but it is the one where it's choosing 5. Because remember the first term, when we did that last one before, the first term it was 1, wasn't it? Second term was 8 choose 1. And then I like to think about it in what power of x I'm having. X to the power 1 goes there, x squared there, and so on. So we're looking for the term in x to the power 5, which is actually the 6th term. But when it comes to choosing, we're going to be looking at 12 choose 5. So pop that in the calculator and we get 792. Then that's going to be multiplied by 1 to the power of, well, it's the 6th term, so that, well, it doesn't really, or if it was another number it would be important, but that was 1 to the 12, wasn't it? So 12 take 5 is 7, so it would actually be 1 to the power 7, and then that would be being multiplied by negative 3x to the power 5. So let's be really ultra careful about this and do negative 3 to the power 5 is giving me negative 243. So I'm going to say I've got 792 times negative 243, and then I've got my x to the power 5. So then I just need to do 792 times negative 243, and that gives me 192,456 negative x to the power 5. Lots of easy ways to lose a mark on a question like that, so don't let it happen to you. Now, when we start talking about a negative power of our bracket, or a 1 over 1 plus kx to the power of 4, it could be written as, we need to start using something else. So on page 5 of your formula booklet, you get this. And the question is asking us at the moment, it's just going up as far as the number of x's. And if you look at what they're asking for there, the very first, the number of x's is just n times what you've got there. But we don't, so what we know is, in order to get that, we would be timesing kx, we times our number there, so instead of just being x, it's kx, so kx times negative 4 is giving us 20x. So if I divide by negative 4, kx is going to be negative 5x, isn't it? If I divide both sides by x, therefore k must equal negative 5. So we're able to say that what we're looking at here is 1 plus, well, not 1 plus, I mean 1 take 5x to the power negative 4. And now we're looking to find what our expansion would be to x squared. So that's when you have another little look at your formula book and go, right, okay, we're going to be using this. So let's just make sure we've all written that out so we're used enough to be able to think about it. So 1 plus x to the power n is 1 plus nx plus n and negative 1 over, and when we did it before, we had it as 2 factorial down here, didn't we? Which is another way of writing it, but this is what you're going to see in the formula book, so let's go with that. So we're looking for the number of x squared, so we need to do this calculation here. N is negative 4, isn't it? But x is negative 5x as far as our formula is concerned, and that is going to be absolutely crucial to getting this right. So I can say I'm going to have for the n minus 1 over 2 times x squared is actually going to equal negative 4 times negative 4 take 1 is negative 5 all over 2 multiplied by negative 5x squared. So that's the crucial bit. What's that going to give us? Negative 4 times negative 5 is plus 20, divided by 2 is 10, times negative 5 squared is 25 x squared, so 250 x squared. So a must equal 250. So hopefully that made some sense, and next pure lesson, which will be next week now, the first lesson of next week, we will be doing more into what happens when this number here is other than 1. Okay.